All right, a little bit more complicated example. We're going to determine the standard form equation of the line going through the points 1, 3, and -2, 5. So that means we have to find three integers, a, b, and c, so that ax plus by equals c is satisfied when we plug in 1 and 3 and we plug in -2 and 5. Okay? So when we plug 1 in for x, so when 1 goes in for x and 3 goes in for y, lost my green, right? Oh, my color coding is off. Let's fix that. Alright, so my x is red. So when 1 goes in for x and 3 goes in for y, and vice versa, if I were to plug in -2 in for x and 5 for y, these equations should both be true. Okay, both these equations should be true. So I'm going to show you two methods. Here's method 1. Step 1 is we've got to determine the slope of the line. So we determine the slope using this equation, m is equal to, our slope equation, which is m equals y2 minus y1 over x2 minus x1. This is also known as the change in y over the change in x. How much up we go when we go some unit across, right? So here's our line, and here's delta x, and here's delta y, change in y, okay? So plugging in our values for y2 and y1, so 5 and 3, and our values for x2 and x1, -2 and 1, are going to give us the value for the slope. So we have 5 minus 3 divided by -2 minus 1, and then that's equal to -2/3 after we do that math. 5 minus 3 is 2, -2 minus 1 is -3, so that's -2/3. So here's our slope right there. Okay, now we're going to choose a point. It can be either one, and use the point slope form to determine the equation of that line. So there's our point slope form, y equals mx minus x1 plus y1, and if you choose 1, 3, for example, then we're plugging 1 and 3 in for x1 and y1, and that's going to be our equation using that particular point. And we would actually end up getting the same equation if we were to plug -2 and 5 in, and so I would encourage you to check that. So you get same equation when you use other point. Okay, so you can check that one. Alright, so now we're just going to use algebra to try to turn this into our ax plus by equals c, where all three of those numbers are integers. Okay, so step 1 is there's a lot of ways you can do this. I just distributed this -2/3 in, and so that gave us -2/3 x plus 2/3 plus 3. Do a little bit of work to combine fractions here. 3 is equal to 9/3. So we have 2/3 plus 9/3, which is 11/3. And that -2/3 x is still there. And then we multiply everything by 3. So if we take this whole thing and we multiply this by 3 on both sides, that's going to give us 3y. And then that cancels with the denominators of both of our fractions over on the right, and we get net minus 2x plus 11. And then lastly, we just add 2x to both sides, and that's going to give us our standard form equation, 2x plus 3y equals 11. Okay, and so here's another method to do the same problem. Determine the standard form equation of the line going through the points 1, 3, and negative 2, 5. So same first step, and I won't go through doing it again, is determine the slope of the line. So using the equation of a slope. And then we note that the slope is also equal to minus a over b. And we did this earlier when we said that ax plus by equals c is equivalent to y equals minus a over b x plus c over b. That's right. Oops. C over b. And so our slope is also equal to minus a over b. And so that's equal to negative 2/3 based off of finding the slope. So that tells us that a equals 2 and b is equal to 3. So we plug in values for a and b into our equation ax plus by equals c, and then we need a point to solve for c. So if we plug in the point 1, 3, for example, that's going to give us 2 times 1 plus 3 times 3 is equal to c, and that's 9 plus 2 equal to c, and so 11 is equal to c. So 2x plus 3y equals 11. And we get the same answer we got earlier. Let's just go ahead and check that this is actually an equation for our line. And to check that, we simply plug in our 2 points, 1, 3, and negative 2, 5, and check to make sure that they satisfy this equation. Both of them do. So when we plug 1, 3 in, we get 2 times 1 plus 3 times 3 is 11. That's what we said earlier. And if we plug negative 2, 5 in, we're going to get 2 times minus 2, which is negative 4, 3 times 5, which is 15, and that also equals 11. And so in both cases, the equation satisfied, so this is the correct equation.